In this video, we're going to talk about two different scenarios, and then the question will ask if it is a proportional relationship or not. So make sure you take good notes. Scenario 1 says the Crazy Fun Carnival charges $2 per ride. So the first thing it wants me to do is fill in this table. So you always want to read the headings in your table. The top row of my table, which I can also label as X, talks about the number of rides. And the bottom row of my table says cost, which I can label as Y. It's going to be like a total cost. So since I know that it's $2 per ride at this carnival, if the number of rides is 0, well, it's going to cost $0. But if I'm going to ride just one ride, since it's $2 per ride, that one ride would cost $2. 2 rides would be 4. 3, so I'm just multiplying it by 2 to get 6. 4 rides times 2, $8. 5 rides times $2 each would give me 10. The question asks, does this table show a proportional relationship? So the notes yesterday was, it had some tables, and it was asking if the table had a constant. So remember that to get the constant, we do Y divided by X. So I can check this table to see if it has a constant, and then I'll know if it is proportional or not. So our tables yesterday did not have 0, 0, but whenever you see that, you're just going to ignore that row, and I'll divide the rest of them. So I'm going to do 2 divided by 1 would reduce to 2. My next Y divided by its corresponding X would say 4 over 2, which is still 2. 6 divided by 3, which is still 2. 8 divided by 4, which is still 2. So every time I'm taking that bottom number and I'm dividing it by that top number. 10 divided by 5 still gives me 2. So it's asking, does this table show a proportional relationship? I would say yes. And I would say the constant is 2. Okay? So with me now knowing that this information in this scenario is proportional, that lets me write an equation to represent this table. All I have to do is replace, that's pretty, I have to replace that K with that constant that I got whenever I divided. So our K that we got was the number 2. So I'm just going to replace K with the number 2, and I just bring down my X. Okay, we're going to begin graphing these scenarios, and I can look at the data in the table and just take them as ordered pairs. So my first ordered pair, or X and Y coordinate from the table, was 0, 0. So I'm starting at the very intersection of the X and Y axis with a point. My next point told me the X value was 1. Remember, we go that way first. We go to the X number. And then the Y value is a 2. So I have this point, 1, 2, that I'm going to go graph. I'm starting from the origin every single time that I need to plot a point. So it's telling me to go right 1 and up 2. Put a point. My next ordered pair from the table said 2, 4. So anytime that you have a table of data, you can just graph it on the graph to see if it's linear. Where does it begin? Does it go through the origin? So I'm going to go, starting from the origin, right 2 and up 4. And put your new point. The next ordered pair says 3, 6. So I'm going to go right 3 and up 6. I have 4, 8 as an ordered pair in my table. Going from the origin, right 4. That's pretty, baby. You did a good job.
Yeah.
Thank you. The last ordered pair in this table says 5, 10. So from the origin, I'm going right 5 and up 10. Okay, I'm going to draw a line through these points as even as I can without a ruler. You always put an arrow on the end of the line. Okay. Alright, so I just graphed an equation. What you really did without knowing was we have this equation and this constant is actually going to be the slope of this graph. Okay, I have a proportional, this is direct variation, so it varies directly. That just means it has a constant, so my line doesn't like change the steepness, it's staying the same constant slope. And remember that slope right here is the same thing as rise over run. So I have the number 2. If I want to change it to a fraction, I can take any integer like this and just put it over the number 1. So I can start from any point and go up 2 and run 1 to the right, and I'll still be on this line. So you can go over here and have your little, remember how we did right triangles for rise over run? I'm just going to start at the second point. Rise 2, run 1. Rise 2, run 1.